Going into page 75, here we're looking at condensing logarithmic expressions. And part of the lesson, and the textbook of course, was to go over what is operating in the background. But a quick review would be if we see, let's say, log of A plus log of B. This is an expanded form. If we wanted to condense that, we would write log, and now take our answer, and it's plus this answer, but remember that this is multiplication, that is A times B, in its condensed form. So we convert a plus into multiplication of the answers. Now in the same pattern, if we have the expanded form log A minus log B, and we were going to put that into a condensed form, that would be log. But now because of this negative sign here, where here this was addition, we had multiplication, here we have subtraction, we're going to have division. And again, this is more fully explained in the lesson from our textbook. So let's take a look then at what we have here. They're asking us to put this in condensed form. So it would be log. Now these are common logs, so it's base 10. So this is subtraction. What do we do when we have subtraction? We're going to divide. So this is 36 divided by 9. And we could actually simplify that to the log of 4. So this was the expanded form. We put it in its condensed form, and we actually simplified it. All right, now let's take a look at this one. Again, this is the expanded form. So it will be log, and again, it's base 10. We don't write that. And this is going to be 3 plus 16. So that's 3 times 16. And this is a minus now. So this is going to be divided by 8. Now we can do some simplification. 8 will go into there once. 8 will go into there twice. So here we end up with log. 2 times 3 is 6. And if we were going to evaluate, which is what they want as well, here it is to 4 decimals. But if they asked you to round to 3, that would be 0.602. Here is to 4 decimals. And again, if you're rounding to 3, that would be 778. The rule is you'd go to the 4th decimal. If it's 5 or more, you'd add 1. 4 or less, you drop it. Keeping those simplified rules in mind, we have subtraction. So this is going to be natural log. This factor in the numerator minus now this in the denominator. And we don't have values, so we can't simplify. Now, another item that we need to review quickly is when you see something like this, where this is actually multiplication and not a plus, we're going to take the value we have before the log or natural log sign, and what that refers to is this coefficient out here actually becomes the exponent of this 6, which will then be that times, we still use that. Now here our value is 3, and we're going to use the exponent 2. So this is basically what we have, which then is the natural log of 36 times 3 to the second, which is 9, which is the natural log of 3, I should say, 24. And if you put that in your calculator, you would get a value for that, which is 5.7807. Now here's the case, if you're going to round off to 3 decimals, you're going to drop this 7 and add 1 there. Now in example 5, translating this from its expanded form to its condensed form, it'll be natural log of 3. Now our 2 is the exponent of 3, and this is division now that we show here as subtraction. So this will be divided by 9 to the 1/2 power, and 9 to the 1/2 power is 3. So that is 3 to the second, which is 9, divided by 3, is natural log of 3, which is, if you went to 4 decimal places, would be this, but rounding it to 3, because of this being a 6, we drop the 6, add 1 to the 8, and get this. Now for page 76, they're asking us to graph these. As we go on to all of what's on page 76, we need to, again, graph these, but we need some kind of handle to get to what do we start with, what do we do, and how do they relate, and what will make this maybe easier for us. Well, if we look at our basic graph of the natural log of x, remember this is to base e, what would that graph look like without having it x plus 8 in parentheses? Well, keep in mind that if we put it from its logarithmic form into its exponential form, our base is e, and this of course equals y here. Our exponent is y, and our answer is x. So if we set up a t-chart and we put in some values for y, 0, 1, 2, -1, again, we just want to get our basic shape of this graph. Now if if y is 0, anything to the 0 power is 1. If y is 1, then e to the first power we know is approximately 2.72. If y is 2, we're going to square e and get approximately 7.4. And if y is a negative 1, we just get the reciprocal of what we had for 1, which was 1 over 2.72. So there's enough points for us to graph. So we get this basic shape. But now we want to know what happens when in parentheses we're going to add 8, which when we do our calculation, it's actually going to shift this over 8 units from 0 to the left, so it's out here. And then we go here, that's our new this was 0, we go over 8. And then we're going to end up with something like, let me see if I can do that properly here. So it's the same shape of the graph, except we've shifted it over 8 units. And our vertical asymptote here was 0. Here our vertical asymptote will be negative 8. That is the opposite sign of when it's in parentheses. And we had done some of this earlier. Now I did this using my fancy calculator here from Mathway. So natural log of this in parentheses. It shifts that typical graph that we saw earlier over so that it's negative 8. All right. Now for example 2, Danielle gave a good model of this. If you were to click on that scan box there. So natural log of n, we know what that looks like from original. Now let's move it down, because in a sense this is your new y-intercept down here. We're going to move it down 4 units. So it's going to be the general shape of this, but we've moved it down 4 units. So in red we would have the natural log of n, but now we're going to shift that down 4 units. Notice it's not in parentheses. If it were in parentheses it would have shifted to the right. But being like this without a parenthesis, we're just shifting that down 4 units. So our graph then will look, with keeping in mind that's our y-asymptote, sort of like that. This would be without the minus 4. So again, our y-axis is our vertical asymptote. In example 3, we switch from natural logs now to the log, and it's sort of in this form that we can convert it to this form, exponential. Put in some values for y. So if y is 0, 10 to the 0 power is 1. 10 to the first power is 10. 10 to the second power is 100. And then 10 to the negative 1 is going to be 1/10. So we get an idea what this is going to look like. So at x is 1, y is 0 is right there. Now when x is 10, which is off the graph, this is 1, so it goes really close here. So you're going to have something like so here. I didn't do that too well, but you get an idea. Now what happens when it's in parentheses and it's x plus 12? Well, again, we reverse the sign and we're going to move this whole graph over 12 units this way. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 out here. So this graph now will look like so. Just shifting that over 12 spaces, and our vertical asymptote now will be a negative 12. Remember, our vertical asymptote here was 0. Okay. And there is a screenshot of number 2 that I didn't show you, showing you what we said. It drops down 4 units. That's your new, in a sense, y-intercept. And here is a screenshot of number 3, where originally it was here. If it was just the log of x, it would be right there at 0 and a 1. Now we've shifted it over 12 units. This is a negative 12 over here. So when it's in parentheses, you move it to the opposite sign. Now for number 4, where we had this, and let's make it a little smaller if we can here. Again, this is not part of the parentheses, so this drops it down vertically by negative 5. So there's our 0, and it takes it down to negative 5. So again, you're looking for the general shape of the graph, and this is how you get to it. Now they tossed in something a little tricky here, because they're asking you to graph this, but this is not in a logarithmic form. This is exponential form. So basically it's y to the y equals e to the x power. Again, we want to see what our basic shape is like. And if we graph this, it's going to be, if x is 0, anything to the 0 power is 1, so it's right there. And if x is 1, e to the first is just 2.72. E to the second power goes up here to about 7.4, just to give you an idea. And then of course it gets close to the asymptote on this side. So the basic curve is like that. Now what happens when we put in there, in parentheses, a negative 5? Does it shift it to the left to a negative 5? Or does it shift it to the right to a positive 5? Well, if you remember what we've been saying, when it's in a parenthesis, it's the opposite sign. So this is going to be shifted, and we could indicate that by just putting some more dots here, over 5 places. 1, 2, 3, 4, 5, a dot there. And then here, 1, 2, 3, 4, 5. Dot there, and up here again over 5, and it gets close to the asymptote, of course, and it looks like so. And if we look at our formal graph on Mathway, you see it's been shifted over. The other one would have been in here close. You shift it over, opposite sign when it's in parentheses. Now I see here in our slides we're going on to diversity indices, Shannon's H and E, which is described in our textbook quite a bit. And when I taught biology, this was the actually the clip art they used to show on our textbook there. So they're showing you various diversities. I'm not going to go through all of this. This would take a long time. But they give you all of this, and then they show you all of this too in the interpretation. Wow. As we mentioned, gets kind of tedious, that it shows diversity in the community. Now, I wouldn't ask you to do this, but I'm not sure how much our textbook's going to do something. So let's see here. We are up to 20 minutes, so I think that's long enough for this.